Up first, something called Finding WY01. Well, oh, Dupont. Okay, I've been collecting up Dupont cables lately to restock, and these are the longer, maybe 20 centimeter male-to-male. Those are the ones I use most often, going from breadboard to breadboard, things like that. So I temporarily have them sorted out in these containers, male-to-male, male-to-female, female-to-female. I really need to get a different container because this just gets all tangled up, but these will go in here. 40 pieces Dupont wire, 20 centimeter cables line jumper, 1 pin to 1 pin, pin connector male to male. 99 cents from Shenglongzi. These took 7 weeks to get here. I'm still building up my collection of the 10 and 20 centimeter versions of all of the combinations of pins and sockets on these things. And of course, we need a sensor module, always. This does not have an easy tear option, so there we go. And that's a beefy surface mount resistor. It looks like it's a very small shunt resistance with some power handling capability. So screw terminals, VIN plus and minus, serial clock data ground VCC, INA219. Let's just go look it up and be sure what it's doing. INA219, I2C Power Supply Monitoring Sensor Module, Bi-directional Current. $1.59 from Access City, 2009. And as usual, reading descriptions, we could probably just go to the datasheet and figure it out. The module itself will run between 3 and 5.5 volt supply, but with that, the purpose is to monitor the voltage and/or current of a whole separate power supply circuit, where you can go up to 26 volts. So then over I2C, you can read out the measured voltage, current, and calculated power. And we have a 0.1 ohm shunt current sense resistor here. I can see this being very useful. You throw a nice little OLED on here and have a power monitoring system. Maybe even data logging capabilities if you want to characterize how something behaves over time. This took 8 weeks to get here. So here's the part datasheet. 0 to 26 volt bus voltage sensing. It reports current, voltage, and power. So here's how this chip would be put to use. You power the chip with 3 to 5.5 volts. You would have obviously pull-ups on the I2C line. And whatever actual load circuit you do want to monitor current or voltage from, you would basically take the positive supply rail for your other load circuit, send it through this shunt resistor onto your load, and at the same time with this resistor now you can do a differential measurement across this shunt resistor, and then knowing the value of the shunt resistor you can calculate the current to the load, then the power. It looks like it has a lot of potential. PC adapters and cables. I would assume this is like a DB something, yes. Gender changer, so that would be typically a PC joystick cable. I think they were used as MIDI interfaces as well. Collecting up parts for when I get an old computer up and running and I want to try some interfacing. DB15 male to DB15 male, male to male, plug, mini gender changer, coupler, adapter, connector. $1.18 from Daily Appliance 2010. So there it is. Suppose you've got a DB15 female socket, maybe the back of a computer, joystick port or something, and you've got a cable that has a female on it. Well, you can use this in between and take that female plug end and plug it into the female computer end. It's just one of those things if you're going to be dealing with computer peripheral interfaces from old computers, just like having a bunch of 10K and 1K resistors kicking around because they're going to be needed somewhere, and those are the standard kinds of things you need. I ordered this a while ago, so I don't know how long it took to get here. While we're talking about this 15-pin computer connector, okay, D-sub or D-sub miniature versus DA, DB, even DC, D, and E. I never really did look into this. We just all call these things DB something or other. So the D-sub is named for its characteristic D-shaped metal shield. Okay, I guess because the top row is wider than the bottom row, from the side it looks like a D. Okay, fine. Canon's part numbering system uses D as the prefix for the whole series and then followed by A, B, C, D, or E, denoting the shell size, followed by the number of pins. The naming pattern is not always followed. Personal computers first used DB25 for serial and parallel. When the serial ports started using 9-pin, they were often labeled DB9 instead of DE9, because this 9-pin shell is a DE. So you'll see DE9 sold as DB9. Okay, that's all I really wanted to check on that tangent. So coming back, that's why this is called a DA15 for this joystick port. So this game control adapter was on IBM PC compatibles, etc. through the 80s and 90s. Traditionally, it was a joystick input, sometimes MIDI devices, but this hardware section is my interest. It includes inputs for a total of 4 analog channels and 4 digital buttons. And if we revisit the old 555 timer, the Apple II used a bunch of 555s in monostable mode to interface up to 4 game paddles or 2 joysticks. The original IBM PC used a similar circuit for the game port. So the external joystick was plugged into the adapter card and had 2 pots for the X and Y direction, and that joystick pot was part of an RC timing network for the 555. Move the joystick, resistance changes. So depending on the position of the joystick and what the resistance on the pot is, you're going to have a different pulse width out of the timer. Software can measure that and figure out where the joystick is. A wide pulse would be fully right, narrow pulse fully left. This is called modules, but it doesn't feel like a module. It's another package of breadboard jumpers. I've been collecting a bunch of these lately, just like the Dupont. Oh yeah, the dreaded Scotch tape. So these are those pre-formed breadboard wires that go exact spaces between parts of the breadboard, like this. So you have proper spacing, guaranteed. You just pick out the right wire and it's ready to go. Sometimes you don't want big DuPonts flailing all over the board, because that can get messy and it might get in the way of what you're trying to do. So good to have stuff around so you can choose the right part for the job. 140 pieces solderless breadboard jumper solid wires assorted cable set DIY 2 to 125 millimeters long. $279 Canadian from One by France, which is shipping from Hong Kong. This was a 7-week delivery. So there's an easier view of what this kit of jumpers actually does. All of these pre-cut and pre-formed leads are breadboard friendly, so depending how many spaces you need to skip on the breadboard to go end to end, you pick up that wire and it goes right down low to the board and you don't have wires all over the place. Electronic IC. This is kind of big to be an IC. Maybe it's an expansion board module. Oh, it's got a bunch of screw terminal banana jack looking things. Oh, hey, is this to convert the ATX computer power supply into a bench supply? How do I get into this? My God. Well, it's well packaged. Good thing there's no static sensitive parts, because this would have been dreadful. It's just switches, terminals, fuses, and LED in a resistor. Okay, so this is a breakout board that takes a computer ATX power supply, which has all these voltage rails, plus and minus 12, plus 5, 3.3. It breaks those pins out. It's got fuses for all the rails. That's good. It's got a power switch, I guess an indicator LED, nice beefy traces, because some of these rails can do a lot of current. ATX Power Supply Adapter Changer Module, XH-M229, Desktop PC Board 24-pin, $4.69 from New Star 2018. This was an 8-week shipment delivery time, and this allows you to plug in an ATX power supply cable from a computer power supply and break out all of these voltage rails. You get an on-off switch, a power indicator LED, and 4 fuses. I didn't check the fuse rating on mine, but I've seen other people say that all 4 fuses, for them at least, came in at 20 amps arbitrarily. So those fuses may not be properly rated to handle the rails, especially when you consider different power supplies are going to have different power ratings, like 200 watts, 480 watts, and more. At least there's a provision there. So if you have an extra power supply from an old computer kicking around, doing something like this will allow you to potentially put it to use. Although there are some things to consider. So one of the big unknown, unclear items, do certain power rails need to have a certain minimum current load on them if you're not going to be drawing that much power? Will you possibly need to throw a power resistor across the rails of some of these to make sure the thing powers up properly and is properly regulated? Another topic is cross-loading. But what are the answers to all these things? Basically, from what I can see, the only way to know may be to just try it. So there was ATX, and then there's ATX 12V, different versions. I've tried reading through many different sources of information. ATX requires the power supply to produce 3 main outputs, 3.3, 5, and 12, then some lower power outputs, minus 12, and then the plus 5 standby. So we have this pin power supply on, which when you ground, powers up the whole unit. But what about the minimum load or cross-loading thing? I tried looking at some of these ATX specifications and such. Ultimately, I can't really find anything solid about minimum load. April 2013 revision 1.31. The 12-volt 2 rail has minimum loading requirement. It must meet the minimum current recommendation as below. I kind of find this confusing. The requirement is the 12-volt 2 rail, minimum current 50 milliamps, recommended minimum current 0. I don't know the difference between minimum current and recommended minimum current, especially when it's a requirement to follow this. Okay, well, go with the worst case. We have to draw at least 50 milliamps out of the second 12-volt rail. Okay, no problem. Now, I didn't see anything else explicit in here about a minimum current draw requirement for proper operation on any of these rails. Some power supplies will have their own built-in load resistors to make sure that any minimum requirements are met. And I've seen other ATX power supply specs online. One of them, it actually, for that specific power supply, it said the 5-volt rail had to have minimum 1 amp. But all the other rails had 0 current draw requirement. So I think it ultimately depends. So again, on Wikipedia, giving some external links, a short history of power supply voltage rails and some other stuff over at playtool.com. So they talk about voltage rail complications you could have. Cross-loading problems, unbalanced current. Controlling the 5 and 12 volt output involves adjusting the size of power pulses going to the main transformer. If it tries to adjust one of the voltages, it'll affect the other. So the 2 voltages are closest to their nominal correct values if their loads are balanced. If one's heavily loaded and the other's not, there may be problems. So that's the whole cross-loading thing. And as I have also noticed, they are saying that PC power supply manufacturers publish sketchy specs, and they rarely publish cross-loading information. In certain power supplies, you need to load the 1 voltage rail with at least a certain amount of power draw in order to safely use the other rail at its maximum wattage. So the point is, this is a big can of worms, just simply hoping that we can take a computer power supply and break out the pins, enable it, and then just use whatever power within the limit of the supply spec, however many amps on a certain rail. Maybe we have to draw certain amounts of power on certain rails for this reason to make sure things run properly. But again, how do you find the exact info for your power supply? Coming back to the ATX Power Supply Design Guide, can we do anything catastrophic here? Output protection required. So if there's no load, no damage or hazardous conditions should occur when the DC output is disconnected from the load and the power supply may latch into a shutdown state. Although it says with all the output connectors disconnected. Well, what if you try to use one rail? So, again, I'd rather not have a story. I'd like to see some data. Overcurrent protection should be designed to limit the current to operate within safe conditions. And the recommended overcurrent protection is to put the power supply in a shutdown state, but that's recommended, not required. If I try to draw too much current on some rail, I hope the power supply will shut itself down. I think where I'm getting at is I just really have no way to know what performance to expect out of the power supply using it as a bench supply. Maybe I can do what a lot of projects do and just arbitrarily load down 5 volts with 1 amp, 12 volts with 1 amp, and then just draw on top of that whatever I want, and not really use it as a main power supply. But if I have a specific application I want a lot of current, I throw an extra 1 amp on it for good measure, and then I draw my 10 or 20 amps for whatever I'm doing, and everything should be good, right? So a minimum load may be required before the power supply outputs are stable. Many power supplies have internal power resistors to draw the minimum load, so you don't have to worry about that. So in that case, maybe just by probing the output when we power it up, we can see, does it look like it's taking care of its own regulation? And if not, hopefully it just shuts down to protect itself. So just pointing out, there's a whole lot of things to consider if you want to just use an ATX power supply as a bench supply. If you want to throw some power resistors on there just to be sure, then you'll probably have a lot easier of a time. I wanted to see how I can figure out if I even need the load resistors or what the current draw should be, because it looks like the more I look into this, the more uncertain it is, unless you just arbitrarily draw 1 amp everywhere. Do your own research and see what makes sense for your application. So I found this old 480 watt ATX power supply. So this can do 28 amps on the 3.3 volts, 36 amps on 5 volts, 16 amps on plus 12, 800 milliamps on minus 12, and half an amp on minus 5 volts, and 3 amps on plus 5 standby. That's a lot of power. I got this around 2007 or so, which this label kind of confirms. It looks like December 2007, although they also have 2006 checked off, but whatever. Sounds about right. So here's the mess of hard drive cables. It looks like we have the old style and some serial ATA. I forget, is this a standalone fan power supply? And the main ATX motherboard connector with the removable extra 4 pins. So what does this take? All of this? It goes this way. Yeah, this takes the whole thing. Okay, so we plug all this in. So I'll turn on the switch for the power supply itself. So let's see what happens. Here goes nothing. Ah, the fan's moving, lights on. Okay, so this is the minus 12 volt rail. It's kind of hard to get all of this in view. Okay, on the minus 12 rail, we have a minus 11.39. On the plus 12 rail, 12.2 volts. On the plus 5 rail, 5.25. Plus 3.3 rail, 3.375. So that is definitely something useful. It makes me feel justified that I keep things like this around. I have a couple more power supplies too. Maybe I should order a couple more of these now that I know it looks like it'll work. So you turn it off, light goes out, fan stops. I like it. Maybe I can put one of those panel voltmeters somewhere and make a project out of this. All right, this time we got some more Dupont jumpers, pre-formed breadboard jumpers, a new subscriber, a DB15 male-to-male gender changer, INA219 breakout board, and the star of the show, this ATX Power Supply breakout board. I would say this was a success. So thanks for stopping by. Thanks to the Patreon supporters who help make these things possible. As usual, I look forward to putting all this stuff to use. Stay tuned for future projects.